we'll go from current slide. But before we get going on that, I'll actually turn on the projector and just briefly go over. I think you've heard all the announcements ad nauseum, haven't you? Okay, the college fair days, 2 weeks from yesterday and today, 9:30 to 11:30, Birmingham, Wednesday, Bessemer, Thursday, and the poet summer internship possibility. Okay. That also gave me opportunity to let the screen come on, so I would be writing on a projecting darkness. Okay. Now, where we left off last time, we had started to analyze an electrical network. And all my beautiful drawing from before has disappeared. So let me pick up and go from here. Okay. You have a junction here, junction 1. And they show current coming into junction 1 here, having passed through a resistor there, this being I1 moving in that direction, and this being resistor 1 of 3 ohms. Okay. Where those current came from was a battery, which was 7 volts. I like to make my distinction between positive and negative a bit bigger than theirs, so sometimes it's hard for me to tell. This is plus side, minus side, and this is, they don't give a name for it. I would call this E1 or V1 or something like this, but that's 7 volts. And coming down here to junction 2. In between, and of course it's still current going in that direction. Okay. Down here, leaving junction 1, you hit another resistor here. That's R2, and this is 2 ohms. And from there, it goes into junction 2. And this is I2 in both places. Okay? Then, also coming into junction 1 is I3, at some point having passed through resistor 3, which was 4 ohms. And this is I3 coming in here because it has a source back here of a battery that was 8 volts. Okay. Okay. Now, we got that far, and I think we wrote down the first equation, didn't we? The unknowns here are your currents. You know your resistors, you know your batteries, but you don't know is the current. And Kirchhoff's first law, which is the junction law, says the sum of those coming in equals the sum going out. It's about conservation of charge, basically. Or you can write that the sum of all the currents coming and going is 0 from a node. You don't build up current in a node or a junction. So you have I1 coming in, I2 going out, so that's a minus I2, and I3 coming in, and the sum of those currents is 0. Okay? Now, if you went to node 2 and did the same thing, you would have minus I1 because it's going out, plus I2 because it's coming in, minus I3 because it's going out, and that would equal 0. That would be exactly the same equation as that one, only the negative of it. So that is those two are basically the same equations, or dependent on one another. So we won't list that. So the next thing we do, we have to have three equations to solve for three unknowns, the three currents. So the next is going to be the best choice here, and we talked about this before, is the interior circuits. You could do the exterior one if you wanted to, but the best here, let's just assume the current is flowing in that direction. Because you look at it, okay, it's not current flow. We're going to be counting around that circuit. We're going to measure our increases and decreases in voltage around that circuit. And we're going in that direction. Down here, we'll go in this direction. Okay? This is Kirchhoff's loop laws. Okay? Or closed path laws, whatever you want to call it. Second law that deal with the paths. So let's just pick us a starting point on path 1. And I think they name it, so they'll call this path 1. This one up here. So let's just start with this point right here. And we're looking at voltages. Okay? And I'm going to write this here, then I'll adjust it for over here. Okay? Beginning here, I run into 7 volts, and that's a positive 7 volts, going up in 7 volts, from negative to positive, increase in voltage of 7 volts. Okay? Next thing we hit is a resistor here. Okay? And the you haven't had Ohm's law yet, you said, right? In okay, physics. But what you have here is you have a drop in voltage of IR. Well, I is I1 and R is 3 ohms. So you have a drop in voltage of 3 I1. Okay? Ohm's law is E is equal to IR. And E or V, you could use either one of them. In the old days, they used E for electromotive force, but it's not a force, so they sort of quit using that. They moved it to use E for energy, so they moved for V for this one. So whichever you use, okay? But that is your voltage drop across the resistor. Okay, continuing that loop, we went through the plus 7 minus 3I1. Then you got down here to I2. And here you go through R2. R is 2 ohms, so that's a minus, minus 2 I2, because you're now in current number 2. Okay? And then you go back here and back up here. That's equal to 0. The total change of voltage in any closed loop is 0. You got a plus and 2 minuses. Okay? Now I want to turn that around and put our unknowns, the i's on the left-hand side and the knowns 7 on the right-hand side. So that's just going to be 3I1 plus 2I2 is equal to 7. Right? So that'll be my second equation. 3I1 plus 2I2 is equal to 7. Okay? There's my second equation. Now, let's do the same thing for down here. We're going to travel around this loop in that direction. So I'm going to pick that point right there. You can pick any point you want to. I just sort of like to start here. So that'll be my starting and ending point as I make my loop completely around here. First thing I get to is I go in this direction is a plus 8 volts. Then what would be next? No, this one is, you're going to get to that, no, cross them up. R3 is 4. Yeah, minus 4 R3, I3, I'm sorry. Next. Yep. 2I2, right? And that's going to add to 0, because you get all the way around, the junction doesn't give you anything. Get all the way back to that point. You close the loop, so you've got 0. And this is conservation of energy, because voltage is energy per charge. So you went up 8 joules per coulomb, you went down and went down, you came back to 0. Moving those two around gives me 2I2. Go on, continue. Plus 4I3 is equal to 8. Okay. What are you going to do with that system of equations? Sounds like a capital idea to do in a linear algebra class. Okay, so what would that matrix be? Okay, start with that one. The top one. 1. Minus 1. 1. 0. Next. Was that 3 you said? 3, 2. 0, 7, right? Okay. And the third one? Whoa. I1 is 0, right? 2, 4, 8. Who do we appreciate? Okay, never mind. Okay. All right. Now, anything you want to do first? Okay, that's certainly a good idea. And I don't know if it's advantageous to do it yet or not, but when I look at that third equation, it's only because you just said it that I even noticed it. What can you do with that third equation? Yeah, let's not. Just looking at that third line, third row. Divide by 2, yeah. Okay. So let me just do that. Be 1, 2, 4, right? So I just don't like messing with any bigger number than I have to, okay? So it'll be 1, 2, and 4. Now, I can't think of anything else to do that easy. What I just did was row 3 divided by 2 is row 3, new row 3. All right, and you're absolutely right. The next thing we want to happen is that 3 to become a 0. How do we make that happen? Row 2, and that's the new row 2. Okay, I'm going to see if I can squeeze this in over here. I'll cramp it up a little bit, but I think I can live with that. We're using the first row, so let's just write it down. 1, minus 1, 1, and 0. New second row is 0, 6. Wait, is that 6? Wait, let's back up. Is that really a 6 there? 5, okay. Leading me astray here, honey. Shame on you, okay. Next. -3 and 7. Good deal. Yes, ma'am. You can, if you need to do something. Okay. I'm sorry. Oh, I put them on the cart, on those brown paper things. Yeah, okay. All right. And we're okay with the third row as it is for now, so we'll put 0, 1, 2, 4. We could have waited and done it, changed it now. So I'm going to pretend we did. I'm going to put this 2, 4, and 8 here and do row 3 divided by 2 is the new row 3. Okay, and that's how you got that. Okay, that's a little more official looking. Okay? Now, what's the next thing you want to happen? Okay. There's several ways you could do it. How would you suggest? I can think of 2 anyway.
We could do row 3 times -5 add square root 2.
Okay. That would make the 5 a 0. Which is not a bad idea either if you do what else? The easiest way to get a 1 there is to flip the rows. I'm all for easy. I'm lazy. You're too hard a worker. Okay? So, let's flip these 2 rows. That's going to be my terminology. Row 2 interchanges with row 3. Okay? So the next entry here will be, we haven't messed with the top rows, so it's 1, -1, 1, and 0. And then we have a 0, 1, 2, 4, and a 0, 5, -3, 7. What you want to happen next? Yes, very good. You're going Gauss-Jordan, reduced row echelon form. So let's, how do you get that to happen? Yeah, row 2 plus row 1 is the new row 1. Perfect. So what's that new row 1? 1, 0, 3, 4. Okay. We're using row 2, so leave that alone. 0, 1, 2, and 4. Now what you want to happen? Okay, -5, row 2, plus row 3 is the new row 3. Okay, so what will it be? Zero, 0, -13, one of my favorite numbers in all the world, right? And never mind. Next. -13 again. Oh, now I don't mind it too badly. If it'll write, but it won't. There we go. Now, what might you suggest we do next? Absolutely. Now, I'm going to cheat because I've got a magic pen up here. What I'm going to do, that would make the 0 a 0, the 0 a 0. The next entry would be a, whoops, I thought I had a magic pen. A 1, and this will be a 1. Wasn't that special? Okay. Now, what do you want to happen next? Now, you could at this point stop and do back substitution if you really wanted to. Since we come this far, let's go on and do your reduced row echelon form, Gauss-Jordan. So what do you want next? Goodness gracious. It's just flicking out.
We want to get rid of 3 and row 1.
Okay. How do you get that 3 in row 1 to go to 0?
You multiply each row by a number.
Okay. Multiply row 3 by a negative 3 times row 3 and add it to row 1, right? That's the new row 1. So that would be, let's see if I can really crowd them in here. That would be, what's your new row 1? I'm going to write down row 3, 0, 0, 1, 1. Because we know I3 is going to be 1. Okay, we know that because that third row tells us that. But 1 amp, by the way, is what you measure currents in. All right, now, what's the new row 1? 1, 0, 0. Is it? 1, yeah, that's good. Now, well, okay, so what you want to happen next? Okay, 2 to become a 0, so how do we make that happen? Perfect. It's the new row 2. Okay? I don't know where my pen gets really slow. And what will that new row 2 be? 0, 1, 0, 2. All right. So here we have I1 is equal to 1 amp. From the first row, you have I2 is equal to 2 amps from the second row, and I already wrote in I3 with 1 amps. Okay. Something very encouraging is that 1 plus 1 is 2. Okay. Good deal. 1 amp coming in there, 1 amp coming in there, and that gives you 2 amps going back to 2, so that's good. And we did everything else okay on the others, so sure enough, that's solves the network, okay? And it's a pretty, oh, I forgot to put in here, not that it matters, this is your path 2. I would call it loop 2, because I'm used to calling loop law. It's nice and alliterative. Okay. And that's what they got to. I1 is 1 amp, I2 is 2 amps, and I3 is 1 amp. All right. Want to do another one? That was so much fun? Sure. Okay. Determine 6 currents here. We could be here a while. Okay. Let's see if we can get it drawn here. We'll start here and go down and hit a battery. Minus to plus, and that's going to be 10 volts. Okay? And then we go down here and hit a resistor. And by the way, this is going to be our I1 here. And that resistor here, R1, is going to be 2 ohms. Okay. Then we'll head over here to our first junction. We'll go up from there, or some direction from there, hit another resistor, and go to I2, go to node 2. And this is our R2. It's going to be 4 ohms. I can't write. That's supposed to be an ohm. It's a pretty ugly resistor too. And this happens to be, and they indicate here I2 is going upward. Oh, I meant to say this before too. Should it have bothered you on that last one we did if we wound up with a negative current? Does that something you could have? Yeah. All it means is you put the arrow in the wrong direction. Just go and flip that arrow. You would have had it. Okay? Now, this I2 right now is indicated it's going from 1 to 2. So that will be our I2. All right. Just to the east of 2, we run into another battery, and this is 17 volts. Pretty big batteries on this one, and we figure that current going here is going to be our I4 for some reason, just to duplicate what the book has, and it runs into resistor R4, which happens to be 2 ohms. Okay. That heads us into node 4, or junction 4. And let's go back down to 1, and go to the right here from 1, and you hit resistor 3. I can't get my pen to write. Okay. Resistor 3 is here. And resistor 3 is a little old 1 ohm resistor. And we have the current leaving there to be I3. Okay. That's what made I4 up there. This runs into node number 3, or junction 3, which I'm not sure why they put it down there, but they did. And coming down from 4, we hit another resistor here, and that's going to be our I5. Oh, I'm sorry. The current coming through here is I5. The resistor here is R5, and that R5 is going to be 2 ohms. All right. One more loop over here, and that's going to have nothing on the north side. And you do run into a 14 volt battery with the plus on the top and the minus on the bottom, and this is 14 volts. Okay, just below that we have a resistor 6, and that's going to connect over here to 3. So resistor 6 is 4 ohms. Okay, and this current here is going to be current 6. You could have drawn that anywhere. The top, bottom are over on the right. They drew it on the right. I did too. More room otherwise. Okay, we have 4 junctions, and we have 6 currents, and we have at least 5 resistors. That's all, no, 6 resistors. Yeah, 6 resistors. Okay. And now they chose some pathways here. You could choose them or not. I like the idea of this one going in this direction because it's going up in voltage there. I sort of like to go up in voltage. This one going in this direction, that also is going up in voltage. So this is path 1. Wait, that's supposed to be path. This is path 1, path 2, and this one I would also have going in this direction, path 3. All right. We have 4 junctions and 3 paths. That's 7 equations. However, we only have 6 currents. But it's a little hard to see which one we don't need to do. So let's do them all. Guess what? The math will take care of it, and one of those rows are going to come out all zeros. Hopefully only one, okay? Otherwise, and hopefully it'll come out all zeros and not 6 zeros and a 7 or something like that. That means not going to work. So hopefully this will work. It looks like it should. Okay? You want to start with junction 1. me just to remind myself the currents and which way they're going. At junction 1, you have I1 coming in, I2 going out, and I3 going out. So that equals, well, I'm not going to write it there. I'm going to leave a bunch of room, hopefully enough, equals 0. Total current coming in equals total current going out. Sum is 0. Junction 2, we have going out I1, so let's make that a minus I1 because it's going out. Coming in is I2, and going out is I4. And that's equal to 0. Agreed? I'm going to move my I4 back a little bit. I got a little carried away. Okay. Let's go to junction 3 down there. Okay. You got I3 coming in.
I3's going out. You wrote that arrow out.
I did. Shame on me. You are absolutely right. Okay.
So that means for one, I3's coming into, right? Junction 1.
Yeah, I1 is coming in, so I made that a plus. Oh, but that makes, okay. I3 was going the other, yeah, so I3 is coming in to I1. I see what you're saying. Okay. Okay. So that makes that a plus I3, right? I1's coming in, I2's going out, I3's coming in. Okay. And at junction 3, I3 is going out. Now, this is a little bit of cheating here because I really like the idea of that being a positive number. I'm going to make that positive going out. And that makes I5, did I draw it right? Yeah, it's coming in, so that's going to be a minus I5. And then I6 is going out, so that's going to be a plus I6. I just flipped them around because I wanted that to be a leading line. I was just looking ahead. So it doesn't matter which way you have them going. The sum is going to be 0. So you could multiply that by minus 1, and it looks better that way. But I don't care about looks. I want it to work better that way, so I did it that way. Okay, so that's junction 3. Let's go up to junction 4. And that leads off with the I4 coming in, and I5 going out, and an I6 coming in, I think. And that's equal to 0. All right, 4 equations, 6 unknowns. But we got 3 paths. And again, now, just to re-emphasize this, you can choose any path you want. You could have chosen the whole exterior as a path. You could have chosen the first 2 loops as a path, the second 2 loops as a path, or any one of these individual loops. Okay? You just have to have a complete path. The easiest ones are usually the ones inside because you don't have to look as far. You just look right inside the circle. And they certainly should work okay. But let's see. So why don't we start at this corner here? Okay? And let's go in the direction of path 1. And again, I sort of like to write these by themselves and then translate them to my equations. Okay, first thing I hit is a plus 10 voltage. Then I had a minus 2I1. Agreed? That's a drop in voltage there. Continuing on, I hit a minus 2I2. No, minus 4I2. Your resistance is 4, your current is I2. And I'm back around where I started, so this is 0. Now, translating that to the order I want them down here, that's going to be a 2, oops, wrote in the wrong place. Yeah, 2I1 plus 4I2 is equal to 10, right? Okay, let's go to path 2. Let's just start here at 2. That'll be our start and end place. So first thing we hit is a 17 volt bump up minus a 2I4, right? Minus 2I5. I hope I've drawn these right. Minus I3. And that's equal to 0. Now, don't think they're always going to be this simple. And the reason I say simple, oh, we still got one more though. Yeah, sorry about that. You see, the way we've drawn it, everything's going in the same direction, so these are always drops. If you ever would encounter a current here that you said was going in the other direction, and this was going down here, but if you're going against the current there, it's actually a plus 4, because your drop is in the opposite direction, which makes it a plus. So all these, the drops are minus, so you're fine. But if you ever did encounter one, but all these are arrows are going in the right direction. Yes, ma'am. I can't hear you. Sure. You want to start it now? Okay. You don't mind waiting till what time we get out here? 12:45. Is that okay with you? Okay. I'll be out of here at 12:45 because I don't have it here. I'd have to go down to my office. Okay. 12:45, either here or near my office. Okay. Okay. So. I forgot we had one more resistance. Okay. Here we had a minus 4R2, I2. That's equal to 0. Okay. So let's get that in the other direction. And let's start with the 4I2 plus I3 plus 2I4 plus 2I5. And that's equal to 17, right? One more path. I don't know if I can fit it in the bottom, but let's try. Let's do it here. We can start anywhere we want to. I want to start down here. So first, well, doesn't matter. Well, it doesn't matter. We could go in the opposite direction just to let you see what I was talking about, but let's not do that. Let's do here. and we'll go in the same direction of our path. So we have a minus, we have a drop in voltage of 4I6, right? Then we have an increase in voltage of 14 volts. Then we have a drop in voltage, because it's going in that direction, of 2I5, right? No, minus. Minus 2I5. Agreed? Okay, and that's equal to 0. So let's get them in another order here. 2I5 plus 4I6 equal 14. Okay. Yo! Alright, what you want to do next?
So we need to solve the junction 4.
Second?
So we don't need to solve junction 4.
I still can't hear what?
So we don't need to solve junction 4. Or do
Yeah, I still couldn't quite make out what you said.
So we don't need to do the path for junction 4?
Oh, we already did junction 4 down here. Junction 4 was I4 coming in, I5 going out, and I6 coming in. So it was I4 minus I5 plus I6. It's not a path, it's a junction. That was just I4 coming in, I5 going out, minus I5, and I6 coming in. Equal zero. Huh?
I was thinking we were still doing, I was thinking we were doing 4 equations because we had 4 junctions.
Yeah, those are the 4. 1, 2, 3, 4.
I was talking about what we were just doing,
Oh, the paths?
yeah.
We chose just to do 3.
Okay.
I don't think we'll need any more than 3, because if you do any other path, you're just doing basically a combination of things you've already done.
Okay.
Okay? So I think this will do. This gives us 7 for 6 unknowns. If we wind up indeterminate, we'll make another path. I think this will give us more than enough. I'm hoping it will give us more than enough. All right. So, what's next? Yes, matrix. So give me the matrix. 1 minus 1, 1, 0, 0, 0, 0. You tired of zeros? Okay. Now, next one. It's a minus, isn't it? The way we did it. Isn't that a minus 1? I hope so. This is junction 2. 1 going out, that's a minus 1. 2 coming in, that's a plus 1. And 4 going out, that's a minus 1. Okay? And then the others are 0, 0, 0. The third one now is 0, 0, 1, 0, negative 1, 1, 0. Okay? Fourth one, 0, 0, 0, 1, negative 1, 1, 0. Those are our easy ones, so to speak. Now let's do what's now our fifth one. What's that? 2, 4, 0, 0, 0, 0, 10. Okay. Yep. Okay. Our, whatever it is, sixth one, 0, 4, 1, 2, 2, 0, 17. All right, last one. Okay. Anything you want to do before we do anything else?
You could simplify row 5 and row 7.
Yes, I like it, because why keep bigger numbers than you need to? So I'm just going to make that 1, 2, 5. Is that okay? So I'm going to erase and make it, I thought I was going to erase. Okay. 1, 2, 5. Okay, it's hard enough to erase. 1, 2, 5. 5, okay. And the last one will become a 1, 2, 7. Okay. 1, 2, 7. Okay. Now, a big yuck here. Now, except for filling in the eyes where they look like they belong, the values when we get them, I really don't see that big a need to keep our circuit diagram. I wish we could, but I need the room, okay? So I'm going to wipe out our circuit diagram if that's okay. You've got it, right? Okay. And this is easier said than done, because my pen is so slow. When you have this much on the screen, it completely gets wacko. That's a mathematical term. And since we don't need these over here, I'm going to wipe them out too. Well, I'm going to try to wipe them out. I'm hoping I got them. Yeah, I got them. Okay. Probably could have wiped out that next group too. All right. Where will we start here?
I'll do row 2 plus row 5 is equal to 2.
You could do that. Why don't we use row 1? It's right above it, and it's easier for me to see. Huh?
If you do row 1 and row 2, that 1 becomes a 0.
Yeah.
But also the other 1.
Yes. So we might as well go on and
I thought you want that second one to be a 1.
okay. All right. Well, doing it the way you do it, it becomes a 3, and then we'll have to mess with that, but that's doable. You want that? We can probably always find something to swap with it, and that's what I figured we may wind up doing anyway. So I don't know. Want to do it your way? It's fine. That's a legal move in most states. Well, it's just easier to see. Row 1 is the new row 2. Okay, usually I write it the other way, but it's fine. Okay? So we're using row 1, so let's write it down. 1 minus 1. 1. and then 4 zeros. Okay? New row 2 is 0, 0, 1, negative 1, 0, 0, 0. Okay. Now, where do you want to head next? Row 3 is fine. Let's write it down. 0, 0, 1, 0, negative 1, 1, 0. Row 4 is fine, as far as we're concerned with the first column anyway. That's a 0, 0, 0, 1 minus 1, 1, no wait, yeah, 0. I think. Yeah, looks like it. All right. Row 5 is the one we want to deal with next. Now here, I'm going to sort of follow your lead on it. I'm going to break the rule a little bit. Because, you see, if I add this row to that row, I'm still going to wipe out my 0 here. Right? Whereas I'd have to do a minus 1 of this plus that. That's more work, they're further apart, so let's just add these two together. That should work, shouldn't it? Not the row 2 up there, this row 2 right here, that should work. Row 2 and row 5. Now this isn't normal, okay? And if this gets us into trouble, it's your fault, okay? We'll do this. So this will be row 2 plus, what's that, row 5 is a new row 5. Let's see if this will work. So that gives us 0, 3, is that what you said? Yeah. 0, negative 1, second, 0, 0, 5, okay. I thought, how'd you get that? Okay, 5, got it. All right. Looks like a pain, and maybe we aren't going to be able to avoid that 3 as where our 1 should have been. Doesn't look like we can do it. Okay, next we'll have, just write down row, what is that, 6 and 7, 0, 0 for the first column, 4, 0 for the next column, 1, 0 for the next column, 2, 0 for the next column, 2, 1 for the next column, 0, 2 for the next column, and 17, 7. Strange but true. Okay. Yeah. What you were going to do before would have given us a 3 there. No way we can avoid a 3 there, it looks like. Okay? So, we either need to move row, I can't keep count, 1, 2, 3, 4, 5 up to row 2, or move 6 up to row 2. Do you have a preference? There's a little bit of me that would prefer 6, and here's why. When you're dividing by 4, all those are nice decimal numbers. If you divide by 3, there you need to leave them as fractions, which is fine, but fractions may work for the 4 as well too, but at least
we did row 4, row 6 minus row.
okay. Row 6 minus row 5. That will and flip it up there, right? Is that what you're saying?
Yeah.
No.
I'm saying like if we did
This minus that would give you a 1 here. And then we flip it up there. Is that what you're suggesting?
Yeah.
Huh? No.
If like we did
Say yes, it's a good idea. No, what? What were you saying?
So it's like we did row 6 minus row 5, and we said it's going to be like the new row 5, and then after that, flip row 5
Yes.
and row 2.
Yeah, that's what I'm saying. Yeah. I think it's a great idea. Row 6 minus row 5, and then move it up there. Okay. Can we try to do that in one step without getting too confused? Now, the only thing that I worry about is what do we have left over? Do we have the 3 left over or the 4 left over? I don't know if it matters, but
I want the 3 left over. I don't want that 17.
you're looking ahead, huh? But at least when you subtract, it gets smaller. So what we're going to do is row 6 minus row 5. Is that right? Okay. Ultimately, that's going to become our row 2. All right, let's try that. Now, but what I'm asking is, what do you have left down here? You want the row 5 left down here?
Yeah.
Because, 5 is smaller than 17. Let's try it, okay? I like the creativeness, okay? 1 minus 1, 1, 0, 0, 0, 0. Kind of wish I'd have given this as a homework problem. Okay, now let's do our subtraction first and write it up here. So 0 minus 0 is 0, 4 minus 3 is 1, 1 minus 0 is 1, 2 minus a minus 1 is 3. Tell me if I'm doing this right. Okay. Oh! All right. 0 minus 0 is 0. 4 minus 3 is 1, right? 1 minus 0 is 1. 2 minus a minus 1 is 3, isn't it?
Yeah.
2 minus 0 is 2. 0 minus 0 is 0, and that's 12, I think. I hope. Is that right? 2, where did I leave off? I don't even know where I was. There I am. 3, 2, 0, and 12. Is that right? All right. Now, are we going to shift everything down until we get to that 3? Or what are we going to do? I mean, as long as we count for everything. And I'm afraid I'm going to lose something if I don't do it. So I think let's just shift everything down one. That's okay too, right? Okay. So row 2 now becomes my row 3. So that's going to be 0, 0, 1, minus 1, 0, 0, 0. Row 3 becomes my row 4. 0, 0, 1, 0, minus 1, 1, 0. I hope I copied it right. I believe so. Okay. Then my row 4 becomes row 5. That's 3 zeros. 1 minus 1, 1. And a 0. Okay. Now, this is where things get squirrely, if they weren't already. This is the place we leave the 0, 3, 0, negative 1, blah, 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 right? That's the one we're going to leave, okay? It'll be 0, 3, 0, minus 1, 0, 0, 5. And then the last row will be 0, 0, 0, 0, 1, 2, 7. All right, does that seem correct? Oh yeah, I was wondering, where in the world do we get our 7? We divided by 2. That's where we got our 7. So we don't have 7 volts anywhere here. Where did that come from? Okay, I just lost my mind, that's all. Okay. Yeah. Now, what do we want to happen next? Okay, and how are we doing on time, by the way?
10 minutes.
20 minutes.
10.
10 minutes, okay. What do we want to happen next? Quick review. 1 here, 0 is below. 1 here, 0 above and here. Everything else is fine, okay? So let's take care of that -1 on top. What do we do with that?
Row 1 plus row 2.
Perfect. Is the new row 1, okay? So since I'm going to really be crowding here, so hopefully I don't lose anything. Add those 2 rows together and you get a 1. Got it. And the row 2 stays the same, so it's 0, 1, 1, 3, 2, 0, 12. Amazing, but true. Yeah, exactly right. And the next row stays the same. 0, 0, 1, minus 1, 0, 0, 0. Next row stays the same. 0, 0, 1, 0, minus 1, 1, 0. Next row stays the same. 0, 0, 0, 1, minus 1, 1, 0. All right. Next row we change. How? Plus, yeah, -3 row 2 plus row whatever it is, 6 is the new row 6. Okay, let's do it to it. Now, you're going to have to help me read my writing here. I think that's a 0 following that, isn't it?
0.
Yeah, I think it is. Yeah, that's a 0. -3, I think it is. Because we're doing row 2, yeah. -3 plus 0 is -3. That's the -9 minus 1 is a -10. Okay. -6. Zero, I think. Oh boy. -36 plus 5 is -31. Not liking that, but let's see. And then the next row stays the same. 0, 0, 0, 0, 1, 2, 7. Okay. Now I'm going to erase this mess. I hope I won't regret erasing this. But guess what? If I find we've made an error, then your homework's going to be find the error and correct it. Report back to class next time. Okay, so I don't care. I'm pretty happy with the way things are going, he said. All right. Next, what do we want to happen next? Quick review, we have 1 and 0 is below it, 1, 0 is above and below it. Next we have a 1. Fantastic. and we want zeros above and below. How much time we got? 5 minutes. Okay. Let's do at least one more. So, what's going to be our attack? There's our leading one. So we want 0 there. So that's going to be minus 2 row 3 plus row 1. Okay. I don't have room to write everything, so let's do it here. All right. Minus 2 row 3 plus row 1. That gives us a 1, a 0, and a 0. 2 and 3 are 5, right? 2, 0, 12. Did I do that right? He's got me worried now. Okay. 1, 0, 0, 2 and 3.
So -2 times -1, wouldn't that be a 2?
Yeah. Yeah. This -2 times -1 is a 2 plus 3 is 5. And then I think the rest of them.
Yeah.
Okay. All right. Now, second row, we want that 1 to be a 0. So that's row 2 minus row 3. That's our new row 2. So that will be a 0, a 1, a 0, a 4, a 2, a 0, and a 12. Right? All right. Row 3 is what we're using, so we write that down. 0, 0, 1, minus 1, 0, 0, 0. All right. Now we want to change that 1 in row 4 to be a 0. So that's row 4 minus row 3. That's the new row 4. I did it backwards from what I usually do, but it's okay. Okay. 0, 0, 0, 1, minus 1. Is that a 1? And a 0. Is that right? Row 4 minus row 3. Yeah. And now we see where our row of zeros come from. That row 4 that we just wrote here is exactly our row 5 that we have here. So that's where the redundancy comes. The row 5 is going to become a row of zeros. So I'm going to just throw it away. I mean, I should write it at the bottom. I'm just going to ignore it because I don't want to write a bunch of rows of zeros. So let's move on to row. It was our row 6. It's now our row 5. Yeah. We want that minus 3 to become a 0. So that's going to be 3 times row 3 plus row, whatever we want to number it now. We were calling it 6. It becomes our new row. Let's do it that way. Yeah. Row 5. Okay, that works. Okay. So what does that become? 0, 0, 0. Now the hard work begins. Minus 10. Is that right? Wait, I'm looking at the, wait, I'm looking at the wrong row. I'm at the wrong row, sorry. Goodness gracious. Okay. This is what happens when we get these real big ones. Okay. Minus 3, row 3. I was on the wrong row. This is the fourth entry. No, it's positive 3 times row 3. That's minus 3, minus 10, it's minus 13. Is that right? Okay. And then I just write down minus 6, 0, and minus 31. I thought, hoping we were going to get rid of that, but we haven't yet. Okay. Now, the last one we just write down. 0, 0, 0, 0, 1, 2, 7. Okay. You know what I'm real tempted to do is when I go to hit my eraser, accidentally hit erase all the slide, and I say, oh, yuck, I erased it all. I hit the wrong button. You'll have to finish this on your own. But I didn't do it that time. Okay. We are out of time, so I should have hit it. Okay. Now, I think you see the state that we're doing. Everything's good down to here. That's even good. We'll use that to eliminate those. Then I think if nothing else happens, we're going to flip this and get that one where we belong, where it would be helpful and see what happens. Now, do you want to finish this in class next time, or are you going to finish it at home? Okay. So you've got this last one down, because I won't have it. So you bring this in next time, and we'll start from here and finish it. Okay. Now, I probably gave you your test too soon, but who cares if you have an extra weekend to work on it. Okay. Let me wipe out that, and we're going to pick up somewhere around here. Okay? You're going to fill me in on that one, and we'll finish up example 7. We're almost through with 1.3. Homework exercises here. You can do any of the first 1 through 13 that you want to. We didn't do those in class, so it's up to you. We didn't do 15 in class. You can do it if you'd like. We didn't do 17 or 19, or 17 or 19, but you could do 21, 23, 25, 27, any of these odd ones. They're all in the back of the book, and they're at calchat.com. Don't worry about 29 yet. We'll see if we're going to do any of those. I don't think we will, but we'll see. All right. Good. Have a good weekend. And basically, one reason I gave the test early is that I think everything on here we've basically already done. This last set, they were such difficult problems to type and stuff, I thought, let's just do the other. All right, good deal.
See you Monday.
All right.